This is a video to go over chapter 7 in Furr's psychometric book, and we discuss the importance of reliability. Three key aspects of the reliability are that it's a foundation of a test's psychometric quality, it's fundamental to understanding and evaluating psychological measurement, and it plays an important role in applied practice of behavioral science, behavioral research, and of course in test construction and test refinement. Let's talk a little bit more about applied behavioral practice, right? If you evaluate an individual's test score, it could be really important and shape those people's lives, and therefore the reliability of such a test score is very important. So let's say an example, right? Intelligence tests are used in courts to evaluate, if somebody is eligible, if you want to call it, for a death sentence or not, right? So that score could really literally determine between a death sentence or not for a convicted murderer. Or there are certain special classes that are based on achievement tests or intelligence tests, and kids might be removed from standard classroom and given other opportunities, to develop their talents. Same thing might be on the other end of the spectrum, right? If there's kids with special needs, intelligence tests might be determined what type of additional services they get. And something that everybody probably of you is familiar with is GRE or SAT scores, right? When employers or colleges are using scores like that to hire or promote or give people access, and therefore those tests are really important. So the quality of the decisions based on these test scores really determines to what degree is this test actually measuring the true level of an individual's psychological attribute. And we have two different ways of looking at this: having a point estimate to say, all right, there's a specific value and this is the best estimate of an individual standing on a particular psychological attribute, or we have a confidence interval, which reflects a range of values that can be interpreted as that's where their true score is likely to fall, right? So their logic is, okay, we have an observed score, but that's just an estimate of the true score, and therefore there is a range where that true score should be in, and the score is just, if you have a point estimate, it's a fairly precise estimate of the individual true score, but they actually have a broader range, right? So a precise test would have a narrow confidence interval, and a not so precise test would have a wide confidence interval. And when you look at point estimates of the true scores, typically people just use the individual observed test score, and that's what they use to do that. However, if there are also adjusted true score estimates that do take into account measurement error, right? And they might look at fatigue, distraction, and so on. And for these adjusted test scores, they might give people a test at two different occasions, and then use reliability estimates to adjust the scores. Right? So having a better understanding of what reliability means and what the measurement error is could really lead to a better estimate of the actual true score. And here's an example of different participants taking a test twice, right? And you see, like, people that score low, they tend to score a little bit higher. People that score higher tend to score a little bit lower. So this is an effect that we call a regression to the mean, right? So that's something that can help having a more precise estimate. Again, assuming that the underlying construct is very stable over time. And so the other idea is to have an actual confidence interval around a certain estimate, right? That's giving you a more accurate indicator of where a person actually is. So as an example, let's say you're giving the WISC, the Wechsler Intelligence Scale for children, to a child, and you find that the child has a score of 106, right? So let's say if this is the true score, we could actually calculate a confidence interval and conclude that we are 95% confident that the individual's true IQ score falls between a range of 100 and 112. So 12 point is reflecting the precision of this point estimate. Right? And so how did we get to this? We said, all right, here we take an estimated score, right? And then we have plus 1.96, which is a z-score for the 95% confidence interval, right? This plus 1.96 times the standard error and minus 1.96 times the standard error gives us this estimate, right? So it's a much more differentiated way of talking about test scores, all right? And here again, what you can see is when you have highly reliable tests, right, they will create narrower bands, right? Let's say the reliability of 0.9, right? This test score is really same test score, point estimate, but a different confidence interval, right? So you can see this one is about, let's call it 33 to 41, versus when you have a reliability of 0.5, that confidence interval right now is around 29 to 45 and a half, right? So you see a much broader range of where the actual true score could be, and it gives you a much better understanding of, when we have these point estimates, typically we overinterpret those point estimates, and people are not aware enough of measurement error, reliability, all those concepts. And particularly when the decisions are so important, let's say there's cutoff scores, right? That draw a line in the sand between getting certain opportunities or becoming access to certain services, that can really lead to big important decisions, and they might not be the right decisions.